Are you looking for a great photo filter? I got you. GFP-GAN is a free and optimized model for filtering images, and it can even run in real time. It's also often used for restoring old photos. Here is also a small comparison of those similar models. Using this model is really easy, and there are 3 ways to use it. The easiest way, just try replicate.com. Pick a photo, set the scale, and that's it. No dependence needed. We just need a little time for it to get ready. Sometimes it asks for premium. No worries, just switch your browser. The second way is Hugging Face. The way of using exactly the same, and the quality is the same on both websites. But how can we make the pictures colorful? We go to the website deepai.org and open the Colorize photo section. Upload the photo we improved with the model and click on the generate. I'm going to rebuild an image for you step by step. Going forward, we will be focusing more on explaining the model's code, which might be interesting for some of you. The repository might look a bit overwhelming at the first, because it not includes only the core model code, but also a number of supporting files and libraries. To make it easier, I break it down into 5 main parts. The first part is the file like inference GFPGAN.py. This is basically the starting point that makes using this model super easy. With just a few lines, you can give the model an image and see the restoring output, without diving into architecture or any complex setting. In other words, this part is the fastest and simplest way to test the model and see its real result in action. Part 2. Core model code. The main code lives in the GFP-GAN folder. Adds network pieces like custom unit and some style GAN blocks. Models. Combines these pieces into complete models and pipelines. Data. Handles loading and preparing data sets for training. Utils handle tools for editing images, logging and saving loading. This folder is super helpful if you want to explore the model. For example, to use a different data sets. Part 3. Supporting library. Another important folder is basics. This is a helper library with many parts you can reuse for super resolution and GAN training. It has optimizers, schedulers, loss functions, and even some extra network designs. You can think of it like the engine room that GFP-GAN runs on. By keeping GFP-GAN and basics repeat, the developers made it easier to update or reuse parts without breaking the main system. Part 4. Pre-trained models and experiments. Inside the experiments folder, there is pre-trained model directory. Here you will find the official model weights. These pre-trained checkpoints make GFP-GAN super easy to use. No need to train from zero. You just load the model and start. This folder can also have config files and results from past runs, which help keep track of experiments. Last part, documentation, results, and scripts. Finally, there are some extra folders that support the project. Docs has install guides, how to notes and facts. Results show sample outputs so you can see what the model can do. Scripts gives extra tools for batch jobs or evolution. These are not the core of the model, but they make the repo much easier to use and understand. Next, I will try to show you a real example of how this model is used in real time.